Namaste, my friend, and welcome to NEET Physics with Typical Monk. This is class 1, and we begin where all of physics begins, with measurement. Now sit with a small truth for a moment. Every single number you will ever write in physics carries two silent companions: a unit, which tells you what you measured it against, and a dimension, which tells you what kind of quantity it is. And every measurement you ever make carries a third companion you cannot escape: an error. When Ria first started physics, she thought numbers were just numbers. The day she learned to read the unit and the error hiding beside each one, her whole subject grew clear. Today, one idea at a time, we learn the grammar that every later numerical will speak. Take a slow breath. Let us begin. So what will you carry home from today's class? First, the 7 base units of the international system, the measuring sticks of all physics, the ones every other unit is built from. Second, dimensional formulae and the principle of homogeneity. How to write what a quantity is made of and how to check an equation with it. Third, significant figures and rounding off, how a number quietly tells you how precisely it was measured. Fourth, errors, absolute, relative, and percentage, and the simple rules for how they combine when you add, multiply, or take a power. And fifth, the NEET drills, assertion and reason, match the column, and a full worked numerical, so that everything you learn today you can also score with. Ready? One idea at a time. Let us start with what we measure against. All of physics rests on just 7 base units. 7. That is the whole foundation. Every quantity you will ever meet is built from these. The 3 you will use most are the kilogram for mass, the meter for length, and the second for time. The other 4 are the ampere for electric current, the Kelvin for temperature, the mole for amount of substance, and the candela for luminous intensity. 7 sticks and nothing more. Everything else is a derived unit, a combination of these 7. Speed is meters per second. Force is the Newton, which is really kilogram meter per second squared. Nothing is invented, everything is assembled. And these 7 belong to one shared system, the international system, which we call SI. It is the common language every physicist in the world agrees to speak, so that Arjun in one country and Priya in another mean exactly the same thing by 1 meter. Now, look at this map carefully, because it is how a physicist sees every quantity. In the center sit the base dimensions, mass, length, and time, written as m, l, t. Every mechanical quantity reduces to some combination of these 3. That combination is its dimensional formula. Take velocity. It is length divided by time, so its dimensional formula is mass to the power 0, length to the power 1, time to the power -1. Mass simply does not appear. Now take force. Force is mass times acceleration, and acceleration is length over time squared. So force has dimensions mass, length, time to the power -2. And here is the quiet power of all this: the principle of homogeneity. In any physically correct equation, every single term must carry the same dimensions. You cannot add a length to a time, just as you cannot add apples to hours. Rohan once checked a whole exam formula in 10 seconds this way. If the dimensions on both sides did not match, the formula was simply wrong. Now, how precise is a number really? Significant figures answer exactly that. The significant figures of a measurement are the digits you actually measured, the ones that carry real information about how careful your instrument was. When Raya writes 2.30 meters, that final 0 is not decoration. So 2.30 has 3 significant figures. The rules are gentle. All non-zero digits always count. zeros trapped between non-zero digits count, but leading zeros, the zeros before the first real digit, never count, they only place the decimal. When you multiply or divide, your answer keeps as many significant figures as the least precise number you started with. You cannot become more precise by doing arithmetic. When you add or subtract, the rule shifts. Now you keep as many decimal places as the term with the fewest decimal places. And one more habit: round only once, at the very end, never in the middle. Time to solve a full, neat numerical together, slowly, the monk's way. We want the percentage error in density. Density is mass divided by volume. We are told the mass is measured with a 2% error, and each length with a 1% error, and the volume is a length cubed. Step 1. Write down what is given. The percentage error in mass is 2%, the percentage error in length is 1%, and the volume is length cubed. Never skip writing the given data. Half of Priya's early mistakes vanished the day she started this. Step 2. Recall the rule. For a product or a quotient, the percentage errors simply add, and when a quantity is raised to a power, its percentage error is multiplied by that power. Step 3. Handle the volume. Volume is length cubed, so its percentage error is 3 times the error in length. 3 times 1% is 3%. Step 4. Combine. Density is mass divided by volume, so the percentage error in density is the error in mass plus the error in volume. Step 5. The answer, 2% plus 3%, gives 5% error in the density. That is the full path: given, ruled, power, combined, answer. The same 5 steps solve every error combination problem NEET can ask. Let us make those combination rules permanent, because NEET tests them again and again. First, for a sum or a difference, the absolute errors add. Notice this carefully. Even when you subtract 2 quantities, the errors still add, never subtract. Uncertainty can only grow. Second, for a product or a quotient, the relative errors add, which is the same as saying the percentage errors add. This is the rule we just used for density. Third, for a power, the error is multiplied by the exponent. A length squared has twice the length's error. A length cubed has 3 times it. And one definition to hold on to. The relative error is simply the absolute error divided by the measured value. And when you multiply that by 100, you get the percentage error. Arjun used to confuse absolute and relative. The day he saw that relative is just absolute divided by the value, it clicked forever. Now set up straight. These 5 lines are what NEET actually asks year after year. 1. Know the 7 base units code and the dimensional formulae of force, energy, and power. Force is mass length time to the -2. Energy is mass length squared time to the -2. Power is mass length squared time to the -3. 2. Homogeneity can check an equation, but it can never find a pure number like 1/2 or 2 by hiding in it. Dimensional analysis is a checker, not a creator. 3. In a product, percentage errors add, and in a power, the error is multiplied by the exponent. This is the single most tested idea in the chapter. 4. Significant figures. Multiplication keeps the least significant figures. Addition keeps the least decimal places. 2 different rules. Do not mix them. 5. Some quantities are dimensionless. Angles, strain, and refractive index carry no dimensions at all. NEET loves to test whether you know which ones. Let us drill the NEET way. Remember the 4 options. Option A, both statements true and the reason explains the assertion. Option B, both true, but the reason does not explain the assertion. Option C, assertion true, reason false. Option D, assertion false, reason true. First one, assertion, dimensional analysis can check whether an equation is correct. Reason, every term in a physically correct equation has the same dimensions. Think like Leah, check each statement alone, then check the link. Is the assertion true? Yes. Is the reason true? Yes. And does the reason explain the assertion? Perfectly. Homogeneity is exactly why the check works. Both true, reason explains, option A. Second one, assertion. Strain has no unit. Reason. Strain is the ratio of two lengths. Both are true. And here the reason is the very cause. A length divided by a length cancels completely, leaving a pure number. Both true. Reason explains. Option A. Third one. Assertion. Dimensional analysis gives a numerical constant in a formula. Reason. A dimensionless constant has no dimensions to track. Check the reason first. True. A pure number carries no dimensions. But that is exactly why the assertion fails. Because the constant has no dimensions, the method is blind to it and cannot find it. The assertion is false. The reason is true. Option D. A quick match now. Say each answer aloud before I reveal it. Force, mass, length, time to the power -2. Mass times acceleration. Work or energy, mass, length squared, time to the power -2. Force times distance. Power, mass, length squared, time to the power -3. Energy divided by time. 1 power of time more than energy. And pressure, mass, length to the power -1, time to the power -2. Force divided by area. If all four came to you before the reveal, the dimensional map is becoming yours. Here's a favorite new NEET format. I will read some statements. You silently count how many are correct. Statement 1. Strain and refractive index are both dimensionless. Hold your verdict. Statement 2. In a sum, the percentage errors of the terms add. Think carefully before you answer. Statement 3. Force and pressure have different dimensional formulae. So, how many are correct? Two statements, the first and the third. Strain and refractive index truly are pure numbers, and force and pressure truly differ. Pressure is force per unit area, but the second one falls. In a sum, it is the absolute errors that add, not the percentage errors. Percentage errors add only for products and quotients. That single swap is the trap NEET sets, and now you will not fall into it. Now let me save you some marks. 2 myths that trap thousands of students every year. Myth 1. When two quantities are subtracted, the errors subtract too. It feels so natural. Take away a value, take away its error. No? Arjun believed this for months. But here is the truth. Absolute errors always add, in both sums and differences. Subtraction can make your result smaller while its uncertainty grows. That is the harsh honesty of measurement. Myth 2. Dimensional analysis can prove any formula completely. If both sides match dimensions, surely the formula is fully correct? The truth, it checks the dimensions only. It can never reveal a dimensionless constant like 1/2 or 2 pi. The formula for the time period of a pendulum has a 2 pi that dimensional analysis simply cannot see. A powerful checker, yes, but never a foolproof. Time to test yourself, rapid fire. Here is the rule. I ask, you answer in your head before the reveal. No pen, no paper, just the dimensional map you built today. Question 1. What is the dimensional formula of force? Mass, length, time to the power -2. Question 2. How many significant figures are there in 0.00420? 3. The leading zeros do not count, but the 4, the 2, and the trailing 0 do. Question 3. If a length has a 2% error, what is the percentage error in the area? Area is length squared, so 2 times 2%, 4%. Question 4. How many base units are there in the international system? 7. And question 5. What is the dimensional formula of energy? Mass, length squared, time to the power -2, the same as work. If those came quickly, you have truly understood today's class. Let us gather the whole class in one slow breath. All of physics rests on 7 base units of the international system. Everything else is derived from them. Every quantity has a dimensional formula written in mass, length, and time. The principle of homogeneity says all terms share the same dimensions. It can check an equation, but it cannot find a hidden constant. Significant figures record how precisely a number was measured, and you round only once, at the very end. Errors combined by simple rules. Absolute errors are in a sum. And next class, we set things in motion. motion in a straight line, velocity, acceleration, and the three equations of motion. Do not miss it. And so, my friend, we have taken the first step. It may have looked like just units and a few error rules, but understand this. This is the grammar of every physics numerical you will ever solve, every force you will ever compute, every speed, every circuit, every length. Each one is written in these units, checked by these dimensions, and reported with these errors. Riya, Arjun, Priya, and Rohan all started exactly where you are right now, with this one class. Be patient with yourself. Revise the dimensional map tonight, once, slowly. One idea at a time. You will crack NEET, of this I am certain. If this class brought you clarity, subscribe to the channel so the next one finds you. Until then, keep going. I will see you in motion.